Guys, welcome. This is our study guide. This is probably going to take a couple parts, so let's begin. Here we go. Okay, so first question number one, we have two sides of a triangle, so we're going to have to go ahead and use Pythagorean Theorem here to solve this. So we're going to get 12 squared plus 35 squared equals x squared. Again, the x squared is across from the 90, so we know that's where the square root of x is going to go over there. So I'm going to go ahead and grab my calculator. I got 12 squared plus 35 squared is going to give me 1,369 equals x squared, and then I'm just going to take the square root of that number. And when I take the square root of that number, I should get 37, and there's the first question. Okay. Number two, again, Pythagorean Theorem, we have two sides, 11 and 14. This time I'm going to do 11 squared plus x squared equals 14 squared. 14 is the hypotenuse. It is the longest side. It is opposite. We get 11 squared and 14 squared. And 14 squared, and we get 196. We subtract 121. And x squared is going to equal 75. From here, we're going to have to take the square root of both sides. Now, at the very top of my paper, it says, please leave answers in reduced radical form. So I can't use my calculator here. So I take the square root of 75 and break it down. It breaks down to 3 times 25, which breaks down to 5 times 5. I have two equal factors, which means I can pull it out. So I'm left with 5. 3 gets stuck behind, and it gets stuck in the radical. 5 rad 3. Okay, so there's the final answer. 5 rad 3 and 37 for the first two. Okay, I apologize, but I made a slight error in 2 of my classes. So period 1 and 5, I just mixed up 2 of the rules. So listen carefully. Here we go. Given the side measurements, first thing we check to make sure it's a triangle. So I did 20 plus 21. It has to be bigger than 29. 41 is bigger than 29, so yes, this is a triangle. Now I got to use Pythagorean Theorem to see if it's going to work. I get 20 squared plus 21 squared equals 29 squared. This gives me 841 equals 841. If they're congruent, I know it's a right triangle. Okay? The next one, I'm just going to check this in my head. 5 plus 9 is greater than 10, so I do know it's a triangle. Now we want to classify it, so we're going to get 5 squared plus 9 squared equals 10 squared. I'm going to go ahead and do that in my calculator real quick. So 106 and 100. Okay, my mistake yesterday, in some of the classes I got this confused. Okay, if the right side is smaller, okay, if this is smaller, it's a cube. Okay, so if it's the large side or the right side. So in this case, we have the right side or larger side ends up being smaller. Okay, I know that's kind of confusing. But this guy is smaller, so it's an acute triangle. I did it the other way in first and fifth period, so I made a mistake there. So it should be acute triangle. Okay? Number 5, we do this one. 3 and 15 has to be bigger than 18. 18 is not bigger than 18, so this doesn't work. This is not a triangle. Okay? And then last one, we have sides 16, 21. Those are definitely bigger than 28, so now I'm going to go ahead and square them. Okay, and we'll do that in my calculator. 16 squared plus 28 squared. Sorry, 16 squared plus 28 squared, 21 squared, equals 697, and then 28 squared equals 784. Now the right side's bigger. If the right side's bigger, then we know it's obtuse. Okay? So sorry about the mistake that we might have made. Alright, now we get to our special right triangles. We start with 45, 45, 90. I'm going to start by putting in my signs, okay, right away. So we have x, 5, and y. So I'm going to use a different color, and I'm going to also circle them. Okay, whoops, sorry about that. And we're going to go ahead and get the next one. I'm just going to do all the rules real quick. Okay, so this top one here, x is 5, which means this piece is also going to be 5. Okay. Okay. And over here, it's going to be x rad 2, so I just take the 5 and I multiply it by rad 2. So we get 5 and 5 rad 2. Nice and easy when you know the rule. Next one. Okay. We know the x rad 2 position. Notice the x rad 2 and the rad 2, they line up, so x has to be 19, and the other one's also going to be 19. Okay, and this last one here is going to be a challenging one. 12 is in the x rad 2 position. I'm going to show you two ways to do this. The trick way is take half of 12, so take half, and multiply by rad 2. If I did that, I would get 6 rad 2 and 6 rad 2 for my answers. Okay? Mathematically speaking, I'll use a third color here. We get 12 equals x rad 2. We divide by rad 2, those cancel. And we get 12 over rad 2. Now, I don't like having radicals in the denominator, so I have to go ahead and isolate it. So I'm going to go ahead to get the rad out of there, I have to multiply by rad 2 over rad 2. Rad 2 times rad 2 is 2, and that's going to be 12 rad 2. And then 12 and 2 simplify to give me x rad 2. So mathematically, we can get there via this route, or we can take our rule right here. Take half and multiply by rad 2. But either way, we end up with the answer of 6 rad 2 and 6 rad 2. Now we're at 30, 60, 90 triangles. We got to be very careful that we're setting up these correctly. Again, I'm going to put my rules in right off the bat. But over here, we get 60. Opposite 60 is my x rad 3. Opposite 30 is x, and opposite 90 is 2x. Okay, I'm going to just go ahead and do that for all of them real quick. Okay, so we're actually given the 9, which is the x, which makes this really easy. So when I want 2x, I'm just going to do 2 times 9. That's going to give me 18. And then over here, I want x rad 3, so I'm just going to do 9 rad 3. So that gives me my answers of x, 9 rad 3, and y, 18. Next problem, we have the 2x position. So if I want just x, I have to go ahead and divide by 2. So x should just be half of that, which is 11. And then if I know x is 11, this is just going to be 11 rad 3. So x is 11, and then I have 11 rad 3. Again, we come to a tricky part where the x rad 3, just like in the last one we had x rad 2, is a whole number. So I actually have a rule for this. And it's take or divide by 1/3. So I'm going to say, let's say divide by 3 and multiply by rad 3. If I do that, the x value is going to be 42 divided by 3 is 14, and multiply by rad 3. And I get that value. And then over here, I double it. 2 times 14 is 28, and I get 28 rad 3. And those are my two answers. Again, I'm going to do a red color, show you how we can solve this. If I have 42 equals x rad 3, I could divide by rad 3. Again, I end up with a radical in the denominator, and I don't want that. So what I'm going to do is I'm going to rationalize. So I multiply rad 3 over rad 3. this ends up with 42 rad 3 over 3, and 3 goes into 42 14 times. So either way I get 14 rad 3, either by doing the math or by the rule. Alright, the length of the diagonal of a square is 24 centimeters. Find the length of one side of the square and the perimeter. Remember, whenever we have squares, we're breaking this into 45, 45, 90. And my rule is x rad 2, x, and x. So I'm going to use my little rule, take half of 12 and multiply by rad 2. So I get 12 rad 2 for my side length. The perimeter is adding all four. So I can either add 12 rad 2 times plus 12 rad 2 plus 12 rad 2 plus 12 rad 2, or I know there's four sides because I can do 4 times 12 rad 2. Only the whole numbers multiply each other. So that gives me 48 rad 2. Okay? Here's an equilateral triangle. Now, if squares make 45, 45, 90s, then equilateral triangles make 30, 60, 90 triangles. So let's go ahead and look at this one. So for here, we're going to end up with 60 degrees, 60 degrees, 30 degrees, 30 degrees. And it says the perimeter is 36. So I got to take the 36 and I got to divide it by 3, so each side is 12. Now that I know each side is 12, I can go ahead and put in my rules. Opposite the 90 is 2x, opposite the 30 is x, and opposite the 60 is x rad 3. Okay. I know the 2x is 12, which is one side of my triangle, and opposite the 60 is x rad 3. And that's what I want. I want to find the altitude. So I'm just going to do 12 in for x, but I got to find x first. Right now I know 2x. So x is just going to be half of 12, or 6. And then I take the x and I plug it in for x rad 3, and I get 6 rad 3. And that's the height, or the altitude of the triangle. This last one was a pretty difficult one for our special right triangles, but we start with the 12, and I'm going to start with our rules. X rad 2, x, and x. Remember, we have a whole number 12 in the x rad 2 position, so my secret shortcut is to take half of it and multiply by rad 2, which would give me 6 rad 2, and 6 rad 2. Now this is one of my answers, so I'm going to put it over here. That triangle's now done. I'm done with 6 rad 2. Now what I have to do is I have to go ahead and grab my other triangle, and I'm going to use red to put the rules here. Opposite the 30 is x, opposite the 90 is 2x, opposite the 60 up here is x rad 3. If x is 6 rad 2, when I double it, I'm just going to get 2 times 6 rad 2. Remember, this is 2 times x. 2 times 6 is going to give me 12 rad 2 for my z value. Down here, I'm going to multiply x by rad 3. So I'm going to get x, which is 6 rad 2, times rad 3. Rad 2 times rad 3 is going to give me 6 rad 6. Okay? Now these two I already had done. We'll squeeze these in at the end of this video, but all we have to do is figure out our SOHCAHTOA. So from sine, we get opposite over hypotenuse. That's where I came up with this. And then I reduced it. 5 and 15. 5 goes into 5 once, and 5 goes into 15 once, which is 3. And so we reduce these. This one was a little trickier on tan A because I got 5 rad 2 over 5 rad 7. The 5's cancel. I get rad 7 and rad 2 over rad 7. Rationalize. 2 times 7 is 14, stays in rad, and 7 times 7 is 49, Square root of 49 is 7.